Alright, now I'm going to answer the questions, which is mostly incorrect answered questions in section 3, chapter 1. The first question is test 6, question number 11. This is the one which is mostly incorrect answered question. Newton multiplied by second square divided by meter is equal to what? We should make a small change in this unit. So Newton divided by, we are going to take this second square just below the meter, I mean right here. So it's going to be like this: Newton divided by meter divided by second squared. We know that Newton is equal to force, unit of force. Meter per second square is the unit of acceleration. If we divide force by acceleration, we got mass. So what is unit of mass? Kilogram. So answer will be D in here. Second mostly incorrect answered question, question number 9. Which of the following is not true for object moving a circular path? So an object is moving on a circular path. The question is about that. Direction of tangential speed is always changing. So yes, you are right, because this is correct. This is correct. Direction of the tangential speed is continuously changing, like that. So this is correct. Object is in equilibrium. If an object is moving in a circular path, it accelerates. There is centripetal acceleration. Of course, this centripetal acceleration, it's accelerated motion. If an accelerated motion, it's not equilibrium. At equilibrium case, acceleration must be equal to 0. Acceleration is 0 in equilibrium. Is 0. But when object is moving in a circular path, its acceleration can never be 0 because there is centripetal acceleration always pointing center of the circular path. That's why this is incorrect. Incorrect, wrong. A centripetal force acts on the object, correct. A centripetal force always is change direction of the object towards the equilibrium, towards the center of the circle. This is also correct. Its centripetal acceleration points towards the center of the circle. This is also correct because centripetal acceleration is always towards the center of the circle. So incorrect one is B. It is not equilibrium because acceleration is not 0. Question number 12 is another mostly incorrect answered question. One of the following equation is not true for calculating centripetal force. The centripetal force equation it's coming from the second law of motion. What is second law of motion? Which is m times a. But for circular motion, we write here FC and AC. So this is correct. Next, instead of AC, you can write V tangential speed square over R. So then it becomes mvt square over R. Or you can write instead of AC r omega squared. So it becomes r omega squared. So it becomes m r omega squared. So m r omega squared, this is correct. mvt square over R, this is also correct. So this is incorrect one. A is incorrect. Second question, test 6 is again mostly incorrect answered question. One of them. Which of the following is the equation for force that maintains circular motion? Force that maintains circular motion is Fc, centripetal force. Which of the following is the equation for centripetal force? It's asking. So in fact, these two questions are very similar. Mr omega squared, yes, this is the equation for centripetal force. This is equal to Fc. R omega squared is equal to AC. V2 square over R is equal to AC. Mr omega squared is nothing. So B is correct answer in here. And question test number 7. Question number 6 is the mostly incorrect answered question, one of them. The force that maintains circular motion of the passenger inside the car. So passenger is in contact with the seat of the car. So there must be, wherever the passenger is in contact with the seat of the car. Let me draw the case. Seat is something like this. So passenger is on this seat. So of course there is the friction force between the seat and the passenger. It will keep the passenger on the circular path. This is correct. Force that means maybe Sometimes a car can make a very sharp turn. That's why passenger can slide towards the door. If passenger slides towards the door, so a normal force appears on the passenger by the wall. While wall applies a force, action reaction, which is normal force. This is normal force, and then static friction force between the seat and the passenger. Both of them can be, maybe, centripetal. This is also correct. That's why both A and B may be. That's why I say maybe, not certain. May be correct. Yet both A and B may be correct. Question number 9. A ball is whirled on a string. Then the string breaks. What causes the ball to move off in a straight line? So normally when you whirl a string with a ball with attached to a string, so the ball will follow a circular path. So reason is why? Because there's a centripetal force, and this centripetal force always changes direction of ball. But if the string breaks, which means centripetal force vanishes. As soon as centripetal force vanishes, so then the ball will follow or leave in a direction tangent to the circle. So because of the law of inertia. So that's why the inertia of the ball causes it to follow a straight line path. Question number 15. Because of Earth's rotation, you would weigh slightly less at the equator than you would at the poles. Because. So this is the Earth. And Earth is spinning about its own axis with some angular speed omega. And this is the pole. When the man is on the pole, let me draw at the pole a man. There are two forces acting on the man. One of them is the gravitational force towards the center of the Earth. Second one is, of course, normal force by the surface, Fn. In here, the man's body is not moving on a circular path. So it's just spinning or rotating about its own axis. No circular path. If circle, it's so small. That's why Fn and Fg, because man is not accelerating down or up, Fn and Fg must be equal right here at the poles. Fn is equal to Fg, poles. But we should know for one thing, when you step on a scale, scale measures not directly your weight. It measures initially in fact Fn. However, at the poles, Fn is equal to Fg. That's why you are going to measure indirectly your weight by the scale. Normally, the scale always measures action-reaction forces between your feet and the surface of the scale. Fn will be measured. Scale measures Fn. Scale measures Fn. But when you are going towards the equator, your body starts to follow circular path. If you go more, so it's a larger circle. At the equator, circle becomes the largest. So at the equator, there will be again two forces acting on this man's body. One of them is gravitational force towards the center. Second one is again normal force, Fn. But in here, your body is following a circular path. That's why there's a centripetal force. We know that centripetal force can be written as Fc towards Fg minus Fn in here, because Fg is pointing the center, it's positive. Fn is away from the center, it's negative. So then scale measures Fn. Let's leave Fn alone, gets other side Fn. Fn becomes Fg minus Fc. This tells you that because Fg cannot change your mass, because Fg depends on your mass and g, Fn is changing, because if you compare this to, this is equator. At equator, this is the pole. At the pole, Fn is exactly equal to Fg, but at the equator, Fn is equal to Fg minus Fc. That's why Fn gets smaller compared to that one. And you are going to measure a smaller the scale will measure a smaller value than it measures at the poles. The reason is what? Because there's Fc. Fc is maximum at the equator because R is maximum at the equator. So the radius of the circle gets maximum value. So Fg minus, if I write the equation for centripetal force, mr omega squared. Omega is same for every portion of the Earth because Earth is a rigid object. But R is maximum at the equator. That's why Fn gets a minimum at the equator. So reason what? The mass centripetal force is maximum at the equator. That's Fn is minimum. That's why Fn measures, the scale measures is slightly less at the equator than the poles because centripetal force is maximum at the equator. Question number 2. The force that keeps the moon in its orbit is gravitational force, of course. Earth, this is Earth, and the moon is following a circular path. So, if there is no gravitational force between Earth and the moon, so moon will follow a straight line path, just as every object because of the inertia. But gravitational force between the Earth and moon keeps moon on the circular path. That gravitational force is the centripetal force. Gravitational exerted by the moon, by the Earth on the moon. So gravitational exerted on the moon by the sun, no. Gravitational exerted on Earth, no. Gravitation exerted on Earth by the moon, no. Gravitational exerted on the moon by the Earth, yes. Gravitational force exerted on the moon by the Earth. And test number 8. First question, mostly incorrect answer is the question number 1. Which of the following is wrong about gravitational force? It's a field force between two objects. This is correct. It acts on objects in pairs. Yes, action-reaction pairs. Action-reaction because Earth and Moon attracts each other. Or Earth and Sun attracts each other. Action-reaction pairs. It's an attractive force. This is also correct. The object with a greater mass applies a stronger force on the smaller one compared to force applied by the smaller one to the big one. This is incorrect because these are action-reaction forces, and force is proportional to multiplication of masses, not only one mass. So magnitude of force depends on mass 1 and mass 2. Now, these two objects interact with each other with the force F. This force is equal in magnitude, which is directly proportional to multiplication of masses and also action-reaction pairs. So they cannot be different. Their magnitudes will be equal. This is incorrect. T is incorrect. So it doesn't mean that Earth attracts Moon with a greater force, but Moon attracts Earth with a smaller force. No, they attract each other with equal magnitude of force. Question number 3. The free fall acceleration g above the surface of the Earth increases with increasing altitude. Altitude means height. So let's draw a diagram for this. This is Earth, center of the Earth. We assume the mass of the Earth is concentrated at the center. On the surface, in here, we can calculate the gravitational field strength by knowing the radius of the Earth or the distance from the center to where you are. And G can be written by an equation capital G, mass of Earth divided by square of the separation, distance between the surface and the center. But when altitude increases, when you go up, this RE becomes greater, which is in fact distance from where you are to the center of the Earth. If RE, altitude increases, this means altitude increases. Altitude increases. When you go up and to the sky, altitude increases. RE increases. Increasing RE, of course, causes a decrease in free fall acceleration. So then free fall acceleration G above the surface of the Earth decreases with increasing altitude. This is correct answer. As RE increases, G decreases. And question number 18. Universal law of gravity between two objects is one of the examples of inverse square law because the force is directly proportional to the square of the distance between the two objects. No, F is not proportional to square of the distance. No, this is incorrect because your equation is this. F is equal to capital G m1 m2 over r squared. So r must be in denominator, not numerator. So this is incorrect. C is force. The force is inversely proportional to product of two magnitudes. This says that force is proportional, but inversely 1 over m1 times m2. This tells that this is also incorrect because m1 times m2 must be in numerator, not denominator. The force is inversely proportional to inverse square of the distance between two objects, center of mass. This tells you force is inversely proportional 1 over inverse square of the separation. 1 over r squared. If you make it, so it becomes r squared. It becomes proportional if you turn it upside down, flip it upside down. So this is also incorrect. The only answer is B. Why? Force is directly proportional. Force is directly proportional. Yes, this sign in fact directly proportional to inverse square of separation. So only there is a trick in English in here. Force is directly proportional to inverse square. 1 over r squared is correct. This is correct one because this one and that one same. Question number 2. Gravitational force between Earth and Moon is directly proportional to multiplication of the masses of Earth and Moon. Correct. You are going to multiply Earth's mass and Moon mass because always gravitational force is proportional to multiplication of the mass, directly proportional. This is correct. Inversely proportional to square of the distance between Earth and the Moon. Correct. Inversely proportional to square of the distance. This is also correct. 1 over r squared. Acts on Earth and Moon in opposite directions. Yes, action reaction pairs they are. So their directions are opposite. All are correct is correct answer. Question number 10. If the separation between two objects increases by a factor of 3, how does the gravitational force acting on the object changes? We know that gravitational force is inversely proportional to the separation, 1 over r squared. Question tells you separation increased by a factor of 3, which means r will change to 3r. Let's write here 3r. So 1 over 3r squared. So then square 3 and r, it becomes 1 over 9r squared. What happened? This is 1 over r squared. This is 1 over 9r squared. We divide it by 9. So you divided force by 9. So this says you that force decreased by 9, or you can write this 1 over 9 times f. They are the same thing. F over 9 and 1 over 9 multiplied by f, same thing. So this represents change. Force changes by a factor of 1 over 9. Question number 13. Gravitational force between two masses is 36 Newton. What is the gravitational force if the distance them is doubled? Distance between them is doubled. So 36 Newton is proportional to 1 over r squared. Okay, but distance is doubled. Question is saying that. In this case, you are going to write doubled means r is going to be 2r. So let's write here 2r, but square it. And then it's going to be what? 1 over square of 2 is 4, square of r is r squared. What happened? Then compare this to. You divided this by 4. So that's why 36 also must be divided by 4. 36 divided by 4, it becomes 9. So 9 Newton is the correct answer in here. And 12. Very similar questions, and they are generally mistake. How does the gravitational force between two objects change if the distance between them is halved? This is, again, about the distance. F, we know that is proportional to 1 over r squared. Halved means r changes to r over 2. So instead of r, we are going to try r over 2. Let's write it. 1 over r over 2, but squared. So it becomes 1 over r squared over 4. We are going to square both of them, both r and 2. Flip it upside down, it's going to be 4 over r squared because this goes up in here. So compare these two now. So this is multiplied by 4. That's why force increases by a factor of 4. Increases by a factor of 4. And question number 25 is a minister exam question. Two objects with two specified masses and specified distance separates them. If the distance between them becomes half of the distance of the first time, what factor does the gravitational force change? Same. F is proportional to 1 over r squared. Question tells you that R will be R over 2 because halved, which means R changes to R over 2. Again, so it's going to be like this in this case. So 1 over, instead of R, you are going to write R over 2, but squared. So it will be 1 over R squared over 4. Again, flip this upside down, take 4 in here, it becomes 4 over R squared. Now compare that. So if this is multiplied by 4, so 4 is also multiplied by 4. 4 times increases. So answer is C. Yeah, this is all for this one, because very few number of questions are entered. So it's not maybe so precise, but if you enter more questions or more students enter the result to the zip code, so I can get a precise result, and then my videos can be much better. See you later.